Welcome to our next session in highway engineering. We are in the the course name is transportation engineering. We are in the highway engineering. Under the highway engineering, I hope you are in the chapter 2 geometric design. In the chapter 2, we are in the session 2. We are going to see various elements of geometric design. Means still we are under introduction topic of geometric design. I hope in the previous session you have learnt about factors affecting the geometric design and what are those values you should know, like topography, design speed, those things. Okay, here we will see little more introduction in this session. From the next session you will probably go into the real geometric design where we will solve more and more problems. In this session mostly we are going to see general introduction yet. Okay, so you see the given here various elements of geometric design. What we are going to see, like I told you what will be the geometric design. So in this topic we are going to see, you should know something about the cross-sectional elements. What are the standard cross-section elements available and what to do with those things. These are all standard things already available which you should know, like from the minimum value to maximum value and how to design those things. Those things are cross-sectional elements. Then we are going to see, like if you see side distance elements means, I wish to tell you something, how they define the geometric design in the sense. First we are going to introduce what are the cross-sectional elements available. Then we are going to see some how straight roads, in the straight roads what are the factors going to affect. In the horizontal curves, like when a vehicle is going in a horizontal curves, how it will, that is the third topic we are going to see. First is side distance, second is horizontal elements, and third is like a vertical curves. Consider the curves will be something like this if the vehicle is going something like this. Okay, so what are the geometric design you should consider when you are designing a vertical curves or vertical elements and horizontal elements and straight roads. Hope clear. So you should know our geometric design concept is devised based on just like a general introduction. We are going to see the cross-section elements. Then you will be seeing the things required to design in a straight road, things required to design in a horizontal curves, things required to design in a vertical curves. So like this the three topics has been devised and some intersection features. Okay, so hope it is clear. In this session, in this video particularly, we are going to see the cross-sectional elements. In coming sessions you will be seeing side distance as the next chapter, horizontal elements as the next one, and the vertical elements as the third one from here. Okay, so very clear. So you should know the division is very important. Like you cannot randomly understand there are 12 chapters something like that inside the geometric design. If you are following my lectures, I wish to tell you something. I am dividing the geometric design into 4 parts. One is introduction, still we are under the introduction course. Second is like side distance, means straight road elements. The third is horizontal elements. Fourth is vertical elements. Okay, so we will go into the cross-sectional elements now. So you see the cross-sectional elements, you should understand there is something called features. What are the cross-sectional elements features you should know, and then the geometry. Okay, so I am dividing the sections into some of the features you should know before going and understanding the real geometry or real cross-sectional elements available in the road. So in the features, it is nothing but we won't consider the features inside the road, like what do you say, like below the pavement. I don't care now. The cross-sectional elements whatever I am speaking is above the ground level. Okay, so above the ground level, this is considered, this is the road. Okay, so what are the geometric elements I should see? Those things are covered under this topic. So something called camber, I hope you should know by camber, but we will see in detail. And what are the width of this carriageway, what are the traffic separators available, width of formation, right of way, and other geometric elements. Okay, so we are going to see one by one in detail. Before that, you should understand some pavement surface characteristics. Okay, how the pavement surface will behave. In that, first one is friction, second is unevenness, third is light reflection, and fourth one is drainage. Okay, so I hope you know what is the pavement. It should be drainage. First I will come from the back side. How the drainage character should be of the pavement. I hope it should drain quickly, right? In the road, the water should drain quickly and the water should not get absorbed. That's how the good pavement should be. A good pavement should drain it quickly. So how it will drain quickly? Consider the road should be, if it is like this, it should have a perfect side drain, Okay, so consider this is the pavement. So when the water or rain falls, okay, so the water should drain quickly to the side drain and the water should not penetrate. So the pavement surface uh, should able to reflect the water, and it should be closed at the top so that it won't absorb the water. So the water try to understand if the water penetrates inside the road, and consider the subgrade is not as good, okay, then it will create a problem. So the subgrade will lose its strength when in a long term, when the very big vehicles are moving, so it will collapse the subgrade cannot take the road because of the rainwater has spoiled its rigidity, then the road will collapse. Okay, so the pavement surface, as per the drainage property, you should remember the pavement should be able to have a good drainage property, something like it should immediately clear off the rainwater to the side drain. Okay, so I hope this should be your drainage property. And the light reflection, I hope you know the light reflection, it should be less reflectable during morning and also during the night. Okay, so that's why they have preferred a between color. If you know, if it is a black color, I hope it will be less reflection, and if you remember, the concrete road will have more reflection. Okay, so that's why the national highway, state highways, we are providing a between, and even in national highway they have provided with such color such that the light reflection is already very low, so the road will not create any problem, but the people coming in opposite is nowadays creating a problem. I hope you know. So it should be less reflectable, the pavement surface, and it should have very good drainage properties, like it should not absorb the water, it should drain off the rainwater quickly. Okay, so coming to the third property, so these are the four properties I told you. Coming to the third property, I will show you something like this: unevenness. So take, I will draw clearly, you can see. So take 1 kilometer of the road, okay, and measure all the unevenness in the road. Consider the road is something like this. Okay, so the length of the road, assume I am taking 1 kilometer, and I am going to, sorry. Oh, I missed the figure. So consider 1 kilometer road again, and consider, no, consider I have, it won't be this bumpy. I have drawn it to make you people to visualize. So consider this is the average line, this is how the road should be, right? Okay, I am going to measure, let it be 1 2 3 4 5 6, something like this. Okay, let it be y1, let it be y2, this is y3, this is y4, this is y5, y6, something like this. So I am measuring for all the 1 kilometer. This is the unevenness, understood? The road level should be something like this, but the road, obviously, since it is a man-made, and there are lot of factors which will not make your road a level surface, so there will be some unevenness. So what is unevenness? You can measure the unevenness by ui, unevenness index. Okay, so there is something called unevenness index, which you can measure using something called bump indicator. You can google that if you want. So using that instrument, you can even measure this bump, which is the values I have shown here, y1, y2, y3, these things you can measure from the bump indicator. So what does it, that unevenness index states is, add everything from y1 to y2, it is a cumulative sum, don't get subtracted, add all the unevenness for 1 kilometer, summing all the values of y1 to y6 or up to yn, consider it's yn, add all the unevenness for 1 kilometer. If this value 1500 mm per kilometer, if the unevenness index, whatever I cumulatively summed all the values, if this value is less than this 1500 mm, then the road is very good. Okay, if it is 2500 mm, in the range of 2500 mm per kilometer, satisfactory to drive, but it's not good road, but it's satisfactory. Okay, so you can say it is satisfactory. But when it crosses this 3000 to 3500 mm, Understood? 3000 mm means almost 3 meter, right? When I add a cumulative sum of all the unevenness in the road, if it crosses the 3000 mm to 3500 mm, obviously we are going to have a very high unevenness, so that it makes not a good road. Okay, and if it crosses, obviously we need a repair, or we will have a more amount of bumping in the road. So bumping will create so much of problems for the vehicles to retain its speed, so many problems. Okay, so these are the numbers you should know. Less than 1500 mm, very good. 2500 is satisfactory. 3000 to 3500 or more than 3500, it's not a good road. Okay, so this is one of the other surface. You can pause the video and note down these values. So this is one of the other pavement surface characteristics you should know. Unevenness in the road, and I hope I told you the light reflection, it should be less reflectable, it should not even create any problem, and we have discussed the drainage properties. The final pavement surface characteristic is friction. So if you studied in your school, you would have known some friction theory. I wish to tell you this one. So when using a friction law, when you are pushing the object, obviously consider there is a solid body and it weights acts downward from its COG. Consider somebody is, I will use some other color. When somebody is pushing the object with a load of P, obviously again there will be a friction developed, correct? How much P you are applying, that much frictional force will develop. Okay, and as per the school theories you should know, I hope you should remember, frictional force developed will be directly proportional to weight, and this frictional force, this directly proportionality is taken by a constant called coefficient of friction. This is mu. This is in strength of materials or solid mechanics or school physics. Okay, in highways we will use a formula in the form of F value. We won't put mu, this will be mentioned as a term called F. So F will be our coefficient of friction. Okay, so using this idea, you can pause the video, note down. I have to delete this one since I don't have that much space. So I told you F is a coefficient of friction. In highway we are going to have two types of friction. Consider this is a straight road. When a vehicle is going in a straight road, the vehicle wheel is going to experience, consider the vehicle wheel is moving in this direction, the wheel is going to experience a friction in this direction, something like this, right? Friction will be experienced in opposite direction when the vehicle is moving in opposite this direction. So this is one type of friction called frictional force experienced when the vehicle is moving in a straight road is called coefficient of, not coefficient, yeah, okay. So this term will be called as longitudinal friction because the vehicle is moving in longitudinal direction. Okay, longitudinal friction. So similarly, when when there is a horizontal curve, when the vehicle is trying to turn in this direction, okay, so the wheel will experience friction in this direction, right? Try to imagine that when the wheel is trying to turn in a horizontal curve, where there is a curve in the road, so the wheel will be rotating. The wheel obviously will also move in this direction, and also the wheel will try to move in this direction also. Okay, so this type of friction is called lateral friction. So I hope you try to imagine there are two types of friction we are going to see in highway engineering. When the vehicle is moving straight, it is longitudinal friction. When the vehicle is trying to move in lateral direction or in a horizontal curve, it is lateral friction. Okay, so please pause the video, note down this one. I have to delete everything. So I hope now you know there are two types of friction. Okay, so this friction, this longitudinal or lateral friction, as per IRC, is suggesting some values. Okay, they have done a lot of experiment and created an empirical relation for this friction, and they realized for longitudinal cases like straight roads, okay, longitudinal cases we have seen, so they have suggested a value based on what speed you are traveling, friction will be changing from only 0.35 to 0.4. It won't go maximum beyond this. Means what they are suggesting, the frictional force generated will be assuming 0.4 times of the weight of the vehicle. That's what they are suggesting. Understood? So what they are suggesting, consider I have a bullet of weight 200 kg. So I am traveling in the speed of 80 km per hour, or the friction is very high. So consider I am traveling at the speed of some 40 km per hour. Okay, I am having a Royal Enfield bullet. Consider Desert Storm, that will be approximately 210 kg or 200 kg. So when vehicle is traveling in 200 kg, frictional force experienced by tire as suggested by IRC is approximately, what is 0.4 into 200? I think I need a calculator. I think 80 kg, correct? I think approximately 80 kg will be the force experienced by the tires. Understood? So try to note down these values. The friction, longitudinal friction given by IRC varies between, based on the speed, it will vary from 0.35 to 0.4. Similarly, for lateral friction, IRC has given a value of 0.15. I hope you understood what is the lateral friction when the in this direction, okay, in the width direction. If it is 0.5, try to imagine again same bullet, we will get only 15% of the weight. So the frictional force will be approximately how much? It will be something like 20 kg to 30 kg. 30 kg will be the load experienced. 30 kg will be the load experienced in the lateral direction. So I hope I made you clear. Friction will be, there is a friction, it is a pavement surface characteristics which is going to change the geometry descent. It is one of the main important parameter. There are two types of friction in highway engineering, longitudinal friction and lateral friction. So longitudinal friction varies from 0.35 to 0.4, means 35% to 40% of the weight of the vehicle, and lateral friction is they have given IRC's recommended value is 0.15, which is nothing but 15% of the weight of the vehicle. Okay, so we will use these frictions when we are coming to the straight road concept. We will use this value. When we are using super elevation and horizontal components, we will use this value. Okay, so this completes our features, pavement surface characteristic features. So we will move on to next topic called geometry. So I will introduce geometry one by one. Okay, so you see the cross section. First you try to understand the cross sectional elements, what is available, so before going into the subject. So this is CW, you can see the figure, you can pause and see this one, or I will try to explain. This is CW, this is carriageway, okay, and this is shoulders, okay, this is right of way. Right of way means I have a right for this road. Carriageway is not only the road, carriageway up to the shoulders, they have a rights. Okay, so area of the land acquired for the road is this much. Okay, and there is a side slope, as I told you, for the drainage purpose, and from here the road margin is starting up to here. You can see the road margin starts from at the end of right of way, the road margin is starting, and you can see the first one is the road boundary. You can see the drainage is here. Okay, so the first one is the road boundary. So this is the boundary line up to which the land is controlled by the road department. Understood? This is the road boundary, road's extreme boundary is this case, and this is the building line. This is where the building line is the line. Consider something like this. So consider this is the road boundary, and this is the building line. So you can construct your buildings up to this point. You cannot cross this building line. So you are having a rights to control a building up to this building line, because the road boundary starts from here. Okay, and there is something called control line. So what do you mean by control line is the municipality or the road department has a power to take the land from you in the future. Like now when the future is the traffic is expanding, they will ask your building to demolish, to increase the road width. So like a 2-lane road becomes 4-lane road, 4-lane road becomes 16-lane road, something like that. So they have a power of attorney to take your land up to the control line. Okay, but they will pay you the compensation when they are acquiring this land. So they will pay you some compensation, they will demolish your building. Okay, so this is the control line. You should try to see the municipality's map before constructing on the road. Okay, so where is the building line, where is your control line, where is your land. Okay, so these are the main margins you should know: control line, then the building line, then the road boundary, then the road margin. Okay, then try to understand the shoulders, and this is a carriageway, this is another shoulder. Similarly on right side and left side. And FW is the formation width, means for up to that much we are going to have a foundation. Okay, we have to dig, right? For putting a road, consider you want to excavate, so how much width you will excavate is this formation width. And right of way, as I told you, the area of the land, we will see one by one in detail in coming slides. Okay, so this is the names you should know in the cross section. Okay, so if it is a 2-lane road, consider if it is a 2-lane road, there will be some, or 4-lane road, there will be some median also. Since here they didn't give you, there will be some median also separating that 2-lane roads. Okay, so I hope from this slide I made you clear what is control line, what is building line, and where the road boundary ends, and what is the road margin, and what is carriageway, what is shoulders, what is formation width, and what is right of way. So if you didn't understand, try to at least Google these terms again and see some Google images, you will understand. So have this figure in your note. This is what we are going to discuss one by one in coming few minutes. So the first cross section is camber. Okay, so our main purpose of camber is nothing but we are going to, the road should be something like this, right? We are going to raise the road surface at the center for the only purpose of draining of the rainwater. So only purpose is to drain the rainwater, so that we will have a surface protection, subgrade protection, and also we will have a quick drying. So there are 3 types of, okay, so I hope you understood. The step 1 is the what is camber. We are going to raise the middle surface. Why we have to raise? It will give you a surface protection, subgrade protection, and quick drying. So there are 3 types of cambers you can see. One is parabolic shape we can give, other is straight line you can give. But IRC is suggesting parabolic has a problem of you see, parabolic camber is not good drainage compared to straight line camber. Correct? Straight line is very good in drainage. It's very good, right? But this is very bad in terms of drainage. But when for the vehicle comfort, this crown point is always creating a problem. You understood, right? You cannot have something like this for overtaking, for any operation over the road. This is not comfortable for drivers. Okay, but this is parabolic camber is very good for drivers at the center point. So clubbing this both, they have created good drainage properties here, for good driving properties here, good drainage properties here. So straight at the end, parabolas at the center, straight at the end. This will give you a good camber, good cross section. Okay, so I hope this you got clear. What are the different types and what we are providing now? Okay, so finally IRC has recommended some values. What are the minimum cambers you should provide? For concrete or bituminous road in heavy rainfall areas and light rainfall areas, you should see for concrete they are asking you to provide 2%. For gravel they are providing 3%. For earthen road they are providing 4%. You see, concrete road they are only providing 2%, but earthen road they are providing 4%, because earthen road is very weak, right? If there is a heavy raining, the earthen road will become, that's it. So nobody can access it, and it will the road will quickly damage because there is no surface. It will directly it is going to affect your subgrade. So concrete road they are going to provide 2%. And if you remember, I taught you something in the previous session. 2% we can write as at 0.02, and which is nothing but 1 by 50. We can write in the terms of 1 by 50. 1 by 50 means, again you pick up a right angle triangle, put a tan theta, opposite is 1. For every 50 meter 1 meter rise. So that's what 2% means. Okay, so what do you mean by 4%? So 0.04, which is nothing but 1 by 25. If you see, for every 25 meter 1 meter rise, this will be more steep, right? That's what for earthen roads they are suggesting. Okay, so similarly you can even calculate theta values. What is the theta value for heavy and light rain, and you can pause the video and then you can even calculate your theta values, so that you can try to understand the angles will be even far less than 1 degree, 2 degree, only lesser than 2 degree values is the camber. You cannot expect the camber something like it will be like 5 meter, 3 meters, okay. So the camber whatever we are discussing, don't expect it will be in meters. It will be somewhere around 10 centimeter to maximum 30 centimeter. Extreme is 30 centimeter as per my experience, but you will see in your own problems. So this is 10 centimeter. Understood, right? How much you can't even visualize this in the road. When you are traveling in the road, you won't even visualize there is a camber, okay. That will be very small. So that's what camber means. It's provided for drainage purpose, and these are the standard values given for calculating it, okay. So we'll try to understand by solving a problem. You can pause the video and solve yourself, and then you can compare. I'll discuss in a district road. So where the rainfall is heavy, there is a major district road, it seems, of the waterborne macadam road. Waterborne macadam road is nothing but it's something like an earthen road. Macadam, okay, I will explain that waterborne macadam road. It is nothing but macadam term is there, okay. I hope you remember the macadam type of construction. So we will have a 3 layers of 1 in 36 slope, something like that, for both subgrade and top, and 50 mm aggregates at the bottom, lesser value, and very small aggregates at the top, okay. So macadam road is exactly same, but they will not have a top surfacing like either no concrete, no bitumen roads, okay. There won't be any concrete road or there won't be any bitumen road. The surface will be without dressing. What they will do, they will mix the soil dust with water. Soil dust, take soil dust, only soil, mix with water, it will become a soil slurry, right? They'll put if the road is something like this, okay, all the aggregates are here. So in waterborne macadam road, they will mix a soil slurry, and they will put a top layer of soil slurry. Understood? This is not a cement, concrete, or this is not a flexible pavement. It is just a soil slurry. That's what it means by waterborne macadam road, okay. So they have given the rainfall is heavy, MDR major district road, it seems, of waterborne macadam road, and they have given 3.8 meter wide. Question number 1. Question number 2, they have given it is a state highway of bituminous concrete pavement, okay. Bituminous concrete, it seems, 7 meter wide. So they have given 2 questions. So what should be the height of crown with respect to edges? So they are asking the camber's height at the center, means something they are asking something like this, okay. So, and remember, either it is a parabola or either it is straight line, it doesn't matter. The center line height you can anyhow match with the Pythagoras theorem, correct. So the theta will be same because the camber is measured in slope, right? So the theta will be same if it is straight line or if it is a parabola camber. They didn't give, don't worry, you can just take it as a theta whatever it is given, and then you can calculate the center height, okay. So going inside the answer, you see, for waterborne macadam road and the rainfall is heavy, you can choose from the table. It is 1 in 33. You can see, I will show you the table first. You see 3% is given, right? Gravel or waterborne macadam road, heavy rainfall area, they have given answer 3%. So I took that 3%. 3% can be 3% is nothing but 0.03, which can be written as 1 by 33, right? So 1 in 33. You take this height they are asking. So if total length is 3.8 meter, this will be 3.8 divided by 2, means this length will be 3.8 divided by 2. So this height, and this is theta. So we know tan theta is opposite by adjacent, and as per our case it should be 1 in 33, and that tan theta and h by 3.8 by 2 should be same, right? Obviously, because they are recommending this slope and we have h by 3.8 by 2. So solving this case, we will have h equal to 0.058 meter, okay. Having both the tan theta should be same. And similarly, from the table you get this value for bituminous concrete road state highway, it should be 1 by 1 in 50 because 2%, okay. So 2% can be 1 in 150. So equating that tan theta for the case 2. And remember, for case 2 they have given length 7 meter, okay. So the center height will be 7 meter by 2, right? So 7 meter by 2. So having both the slopes 1 by 50 opposite by adjacent, it should be equal to this is h by this is 7 by 2, h by 7 by 2. Solving this, you will have h is equal to 0.07 meter, so which is approximately, is it correct? So this is approximately 58 centimeter and this is approximately 70 centimeter. Oh my god. Okay, so verify your calculations. Actually I did it now. You verify this calculation again. If you are getting the same answer, then it's very good. Okay, so going to the next question. Okay, so I will stop this. You can try different types of camber problems. The step 1. Okay, so the step 1, go pick the table values. Okay, step 2, draw the given case, draw the case. Step 3, equate the tan theta, equate the tan theta, then you will have your answer. Okay, so next geometry. Okay, next geometry is width of carriageway. You can see the blue color line, so that is the width of carriageway, and then no, there should be, it is a seal width and then they will have some extra width here. Okay, you can see the figure clearly here. From this point to this point is the carriageway, and width of carriageway is given as for single lane road. Single lane road means, if it is a single lane road, remember the standard vehicle dimension, if you remember, approved by IRC is 2.44 meter, and this side 2 feet clearance, and this side 2 feet clearance. So if you add everything, 2 feet means approximately 0.6 meter, you will get 3.75 meter. That's how you got single lane road. If it is a 3.75 meter for single lane road. Okay, similarly if you take a double lane road, if there is a 2 vehicles side by side, and as per IRC we know this is 2.44 and this is 2.44, and have a clearance of 1 meter between the vehicles. This side 0.5 meter and this side 0.5 meter will give you approximately 7 meter. And there is something called curbs that we will see in 2 or 3 slides. If they are providing a curbs, it should be, curbs should have 0.25 and 0.25 separately, so the total width is 7.5 meter. Okay, if it is intermediate carriageway, something like if there is a multi-lane roads, each lane is 3.5 meter. Okay, that is the 4th case you can see. And intermediate carriage means something near the toll gates and all, you can see the lane road width will be approximately 5.5 meter. So try to memorize these values. This is very common and standard, we are going to use throughout this highway engineering course. And 7 and 7.5 will be interchangeable. There will be some problems they will give you, unless they didn't give you, always the standard value for a 2 lane road is 7 meter. Okay, hope I made it clear. So you can pause the video and note down, and you can replay the video how this 3.75 and 7 meter came. Okay, so width of formation, as I told you, this is nothing but a adding. Okay, you should remember that there is something called shoulders here. Okay, give me, there is something called shoulders here, sorry. So if you see a head of anybody, anyone's head, even your head from the top, I hope you know we will have some shoulders, right? Okay, anybody's, so okay, it's not looking like a person. Okay, so if you look at his head, consider anybody's head. So this will be, if it is carriageway, this is shoulders, right? So in this concept they have named 2 shoulders. Left side you can see this one, this is a shoulder on right side and left side. Okay, so this is the shoulder, and adding both width of the carriageway and width of the shoulders will give you this formation width. And IRC has given some standard values for different types of road, and based on different types of topography, some values. This 12 meter you should commonly know for national highways. Even if it is single lane or double lane, they will give 12 meter. Okay, this is the standard value you should know. They were asked for some 1 marks. Okay, so remaining everything is lame values they have never asked. Anyhow, for your purpose, for your knowledge, you can pause the video and note down these values. So width of the formation is actually, in my point of view, the what is it is the width I have done in my side when I have a problem, when I have to connect between two ports. When I was working in port, I from point A to point B, what I did is to excavate a road, something like this. I used this formation width idea to excavate even that much of width I took. For a 2-lane road, I did an excavation of this 12 meter, and then it came very perfectly for two truck containers to go side by side. Okay, so width of formation, in my point of view, it was like a foundation width also you can use, but in general common terms, as per Kanan and Gusto book, they have devised it as a summation of width of carriageway and plus width of shoulders, and these are the standard IRC values for the width of formation. Okay, you can note down those values. And right of way, as I told you, you can see the figure. Right of way is almost to same. It is also something like how much of carriageway plus shoulders, with some more little margin. Okay, not like the road margin what you have defined. It is the area of the land acquired. Okay, it is how much. It is not like a foundation, right? It is just how much rights a road department has, something like how much area of the land acquired for the road. Okay, along its alignment means laying of center line. Okay, so it is the distance between boundary stones of the road on either side of the road. Okay, sometimes right of way are left vacant. See, these extra portions are left vacant after the initial roadway facility for only for the purpose of future expansion. So how much is the right of way they will acclaim? So you can see for normal right of way operations, if it is national highway, they will acquire at least 45 meter, and for mountainous and steep terrain, they will acclaim 24 meter in open areas if there is no problem. If there is a built up areas, they will acquire at least 30 meter length for national highway, 20 meter for MDR, 15 meter for ODR, and 10 meter for at least for village roads. Okay, so this is the right of way, right of acclaim whenever there is a new road is being planned. Okay, so I told you something about curves. You can see the figure. What is the curves? You can see the left side. This is curve, and these are the curves, and these are the curves, and these are also the curves. So curves indicate the boundary between the carriageway and the shoulders. Okay, so it is, you can see this is the carriageway and these are the shoulders, and the curve indicates its boundary. There are 4 types of curves possible. One is mountable curves. Mountable curves means consider there is a vehicle, so it can, if there is any problem, this vehicle can mount and stay here. So easily mountable. That's why the name came, the mountable curves. And its height is approximately it should be a 10 centimeter. And semi barrier type curves, this semi barrier also, it's, as the name says, it's semi barrier. It's very difficult to go above if there is any problem comes. In this, consider this is shoulder and this is carriageway. So to go to the shoulder, it has to little push this height. The total height is 15 centimeter. The tire has to push some height, but when the tire is placed over here, it can easily go away, go to this shoulder. Okay, first you should know why we have to go above the shoulder. Whenever there is a problem, like you are feeling some consider the road is here, so the vehicle A is going in this direction. Consider this vehicle B is coming towards you. You want to go away from the road. You obviously, this will be the shoulder area. You want to go above. If there is a curbs are there in this direction, so if it is mountable curbs, it's very easy to go away from the lane. If it is semi barrier, you have to take some risk because of this one. And barrier type, you cannot go above. Barrier type, we won't provide in the national highways or something. It will be provided something like for this gardening purpose. You cannot go inside, right? You can see this figure where I am drawing here. Yeah, so that is barrier type. Height is 20 centimeter they will provide, and slope is 1:4. Obviously you cannot go. And wherever only for labor point of view, they will keep this curb stone submerged to identify for the labors to difference between up to which much is the carriageway and where the shoulder starts. Okay, when the road is being laid as a new road, for the labor point of view, they will have a submerged curbs also. So these are the 4 different types of curbs: mountable, semi barrier type, and submerged curves. Okay, so these are the curves, and you can see the figure. So other final cross-sectional terms, what you should know is something called a traffic separators. As I told you, the medians, you can see this figure, this is a traffic separator. IRC is recommending minimum 5 meter of median for rural highways, which may be reduced to 3 meter if the land is restricted. Okay, if the land is restricted, you cannot have that much of area, so you can reduce it to 3 meter. And for bridges, in bridges areas, you should have a median of 1.2 meter to 1.5 meter. Okay, so next I have discussed what is shoulders already. So IRC is again suggesting minimum width of 2.5 meter for a 2-lane rural highways in India. Okay, and also as I told you, shoulders are provided along the road edges, and it is intended for accommodation of the stopped vehicles, as we have discussed in the curb location. And you can see another cross section photo I have given. This is the traffic separator I told you, and this is one lane road, this is another lane road, this is one lane 2-lane road, this is another 2-lane road. You can see there is little camber they have provided, and there is a curb stone they have provided, and this is a footpath or shoulders, and this is a traffic separator. Okay, and they have mentioned here it is a 3-lane road actually. Okay, so this is how the cross section will be. Okay, I hope I made you all the terms clear here. And other terms, what you should know, something called parking lanes. You can see this figure. Separate lane in the road itself will be provided for a parking lane with a minimum width of 3 meter in case of parallel parking. Okay, so this is a type of parallel parking. And bus base is nothing but a bus stop. So what IRC is suggesting, you cannot have a bus base near the intersection. Consider there is an intersection, two roads is being connected. So IRC is advising at least keep your bus stop 75 meter away from the intersection, so that there won't be any congestion because of the bus stop, and bus also can stop easily. The traffic will not disturb even the road, and the road will not disturb the road traffic will not disturb your bus peoples also. Okay, so this is what the bus base, the second point is. And the cycle track, you can see the cycle track I have shown you figure here. So when the volume of cycle is high in the city, they will provide at least a minimum 2 meter for the cycle. Where I have seen in France and Germany, there is a minimum width of at least a 2-lane cycle road, as everybody is having a cycle, and this is the main transportation medium here. And guardrails, what you should know, this is the final figure you can see here. This is guardrails. They will provide at the edge of the shoulder guardrails when the road is on the embankment or the bridges, and it is provided whenever the height of the bridges, something like if the road level is going something like this, and even if the height of fill or height of the bridge is exceeding 3 meter, we should provide the guardrails to avoid any collapse of the vehicle from the carriageway towards bottom. Okay, so these are the other points, 1 marks they may ask you, so you should know. So with this we close the introduction part. If you have any doubt, you can ask me in the mail. And with this we are closing the topic, and we are going to proceed a very interesting lesson called sight distance from the next session. Okay, thank you for the long session.